Good morning. So I'm going to do a follow-up video to the previous video about neutrons. This is also about neutrons because they're just because it's all about neutrons. What can I say? You know, neutron decay cosmology. It's the nature of neutrons, especially this aspect I'm going to talk about today, that makes them like catalytic almost in the process of the universe. In that essential, in that, as we've reviewed. Okay, so way you make a neutron, let's make another one. Let's make neutrons. Can make a neutron is down, down, and up. So in my math, somehow instead of purple, it's going to be green. Blue is one charge, red is the other. It's supposed to be yellow. Anyways, down is negative. Up is positive. Two charges, two axes. This is one of my things. It shouldn't just be thought of as a charge, because then you get these weird lopsided structures, but as soon as you think of it as axes of charge, then the three-dimensional nature of it, and the three of them, the three quarks, the structure of protons and neutrons all of a sudden develops a symmetry, because you've given it an innate symmetry along one of the axes. But it makes a lot more sense in terms of resonances too. Okay, so down, so let's do one there. Okay. I'm not paying attention. Boop. Boop. Each of these only has one charge, one axis of charge, and then the neutron sums it up. This positive and this negative cancel out, become a photon, because a photon is a positive charge and a negative charge in oscillation, usually a positron and an electron, but this is the thing about it. Okay, so there's one photon, and then another one. So there we go. There's our neutron. And now, just because I'm going to leave this room in a minute, now that we constructed it, we can throw away the parts. Okay, we have our neutron here. So a neutron is a very, very defined, a neutron is small. It doesn't have even, when a neutron decays, let's do this, when a neutron decays and becomes a proton, right? Because one of these photons, two photons, both trapped over gravity, probably like electrons, like phase canceled on, but that means that any perturbation, as soon as there's like a deviance in that phase because of any effect that comes into it or around it, it would fall apart. You only find neutrons in really, really intense gravitational fields, like, you know, nuclei and stuff. Okay, so this is the neutron. It fell apart into a proton, which still has a mass unit in the middle, still one of those photons. But this decomposed. This was a charged pair, positive, negative. There's the positive. The negative is the electron cloud around it. This is what I propose, that basically over the lifetime, what happens is a hydrogen atom, because that's what this is, hydrogen atoms get compressed by gravity and other forces. They become maybe even other elements, but still it's essentially these components. Because the electron gets eventually forced maybe back inside, it becomes a neutron. And then that neutron becomes part of some other element, goes through a boop, 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 process, neutronium, neutron star inverts. You had a bunch of these fly out into deep space where they become these. Now, this is what the important thing is, fine tuning. Okay? The simplicity and elegance of the universe. A neutron has a very, very defined and tiny size. Very well defined and tiny size. When it decomposes into a proton and electron, because this is what it decomposes into with a neutrino flying out there, an antineutrino. Because it decomposed, it's an anti. If it was putting together, it would be a neutrino. This has no defined size. The electron field is as big as it needs to be. The fine-tuning of the universe doesn't even need to be exact. This atom, this decomposition, will expand to fill the gap in energy of the universe caused by the inversion of this neutron a moment ago in that neutron star. The hydrogen chinks. It will expand. It would be as big as the whole universe if that's all there was, right? In theory, the electric field of the electron fills all space. This is how fine-tuning. It doesn't even need to be exact. It will fill exactly as is needed. It conforms to the container. It is not confined to a discrete unit anymore. This is the masterful trick of the universe. This is a very, very particular size. This is as big as it needs to be. Fine-tuning doesn't even need to be exact in a mathematical sense. It's geometrically achieved. So it automatically will fit. Maybe I do something like mental place, whatever. It's ingenious, okay? Well defined, exact size, limited, discrete, amorphous, undefined. This is the miracle, and this is why fine-tuning doesn't even need to be much of a trick as long as you accept the geometry of the neutron decay cosmology, which is also just sensible. Anyways, there you go.